This lab starts with a fascinating reaction made famous by Ira Remsen.
We will begin by measuring 0.1 grams of copper. When measuring small amounts, it's important to use high precision equipment so that we can get the most number of significant figures possible. This way, if there are small changes, we will be able to measure them. I'm going to add the smallest pieces I can, one or two at a time, so that I don't overshoot my amount by too much. It's okay if I'm not precisely on 0.1 grams, but you can see here that I'm very close. Remember to close the door before recording your final measurement.
The next step of this experiment must be done in the fume hood because it produces toxic fumes. Ira Remsen was a physician and an influential chemist in the 19th and early 20th centuries. He founded the chemistry department at Johns Hopkins University. But in his early years, he was drawn to chemistry by some unusual reactions, most notably when he read the line, "Nitric acid acts upon copper." He used his own copper scent to watch the reaction and later recorded his observations in a journal. But what was this wonderful thing I beheld? The scent had already changed, and it was no small change either. A greenish-blue liquid foamed and fumed over the scent and over the table. The air in the neighborhood of the performance became dark red. A great colored cloud arose. This was disagreeable and suffocating. How could I stop this? I tried to get rid of the objectionable mess by picking it up and throwing it out the window, which I had meanwhile opened. I learned another fact. Nitric acid not only acts upon copper, but it acts upon fingers. The pain led to another unpremeditated experiment. I drew my fingers across my trousers, and another fact was discovered. Nitric acid also acts upon trousers. Plainly, the only way to learn about it was to see its results, to experiment, to work in the laboratory. It may take some time for the reaction to complete, particularly if you used one or two large pieces of copper. You may wish to stir or swirl the reaction in order to edge it towards completion more quickly. The mixture may appear as green because of the mixture of the brown nitrogen oxide gas with the blue liquid. Once the reaction is complete and all of the nitrogen oxide is dissipated, the solution will look blue instead of green. Once the reaction is complete, you're going to add 30 milliliters of deionized water. Note that at this time, we have added only the copper, the nitric acid, and the water to the beaker. The only thing that has been removed is the nitrogen oxide gas. So this means that all of the copper that we originally started with is still in the beaker, and we have lost none of it at this point. For our next reaction, we will add a few milliliters of 3 molar sodium hydroxide to the copper solution. You can see that there is immediately a color change, but there is also a change in the clarity, that it is no longer a clear solution, but rather opaque. Next, we will heat this solution and continue to observe the reactions. It will take some time for the heat to cause this reaction to go to completion, and it will be helpful if you continue to stir the reaction. Please note that we have not removed anything from the beaker, and so yet again, we still have all of the copper present that we originally started with. You're going to heat your mixture just to the boiling point. You don't want to heat it too much because you don't want the copper to splash all over the place. You should form a black copper oxide, and once you have reached this point, you can stop stirring and just allow the mixture to settle down to the bottom, leaving behind a colorless, supernatant fluid that contains little to no copper. While your mixture is settling, you may wish to heat some deionized water on a hot plate to use in the next step. From above, the mixture may still look cloudy, But if you look at it from the side, you can see that the supernatant fluid is both clear and colorless. Recall that both of our mixtures, the copper nitrate and the copper hydroxide, were blue, so this is an indication that there is very little copper left in solution. Our next step will be to decant or pour off the clear, colorless supernatant fluid above the solid particles. Decanting simply means to pour the supernatant liquid off of the top of the solid. To do so, we must pour very slowly because we want all of the black particles to remain in the original beaker. This is the first place where we may lose some of our copper, either because it is not completely settled out of the solution in forming a copper oxide, or because some of the black particles may be transferred over to the disposal beaker. You'll notice that there's quite a bit of black copper oxide residue on the beaker, so we'll use the hot water we've been preparing to rinse down the sides. The next step is to add a few milliliters of 6 molar sulfuric acid. As the sulfuric acid reacts with the copper oxide, you want to stir and make sure that all of the copper oxide dissolves. Once all of the copper oxide has dissolved, your solution will again be clear, letting you know that you have a solution. Next, you will add half a gram of granulated or powdered zinc to the solution. Like most acids, the zinc will react with the acid in the solution, giving up some of its electrons and forming hydrogen gas. It will also give some of these electrons over to the copper in the solution. We will also notice the formation of a reddish-brown solid. You should be able to identify what this solid is. As the solid materials settle out, we should notice that the solution begins to lighten in color and eventually turn colorless. To help the reaction go to completion, we may heat the solution a little bit. This may help the sulfuric acid to react with any remaining copper ions in the solution and also help the zinc and acid to react as well.
We have added excess zinc to ensure that all of the copper in solution reacts completely. We may find that there is excess zinc after we have decanted. This will look gray, black, or silver mixed in with the reddish-brown copper. We can add a few milliliters of concentrated hydrochloric acid. While acids react with most metals, including zinc, copper does not readily react with hydrochloric acid, and therefore we can dissolve the zinc, leaving the copper in the solid form and be able to separate that from the zinc. Once the zinc has reacted completely, the remaining reddish-brown copper can be collected, dried, and weighed.